So now consider this problem in which a curve y is equal to f of x is defined by these two equations. X is equal to e raised to t square minus 1 and y is equal to e raised to t cube. And we have to find dy over dx and d2y over dx2, and that is the second derivative. So here first we'll find dx over dt. So x is e raised to t square minus 1. So dx over dt is given by the derivative of e raised to t square minus 1. So now first we'll differentiate e raised to t square minus 1 with respect to t square minus 1, right? And then we'll apply the chain rule. So we can write this notation also. Here we write d over d of t square minus 1, and here we have t square minus 1, and then by chain rule will differentiate t square minus 1 with respect to t. Now the derivative of the exponential function is the exponential function itself. So here we have e raised to t square minus 1, and by chain rule the derivative of t square minus 1 is simply 2t, right? Because here the derivative of t square is 2t and derivative of 1 is 0, being a constant, right? Now let us find out the derivative of y with respect to t. So dy over dt is equal to d by dt of e raised to t cube, and here also we'll make use of the chain rule. So first we'll find the derivative of e raised to t cube with respect to t cube, and then the derivative of t cube with respect to t. So now the derivative of the exponential function is the function itself, that is e raised to t cube, and then the derivative of t cube with respect to t is 3t square. So we have 3t square e raised to t cube, right? Okay. So now the derivative dy over dx is given by dy over dt divided by dx over dt. So dy over dt is 3t square, and here we have e raised to t cube, and dx over dt is given by e raised to t square minus 1, and we have here 2t, right? So now we can simplify this expression. Here this t and this t get cancelled, and we have 3 over 2 and e raised to t cube, and here we have this t raised to 1 because t and t get cancelled, and here 1 t remains, and t e raised to t cube minus we can take e raised to t square minus 1 to the numerator. So we have minus t square minus 1. So we have 3 by 2t and e raised to t cube minus t square plus 1, right? So this is the expression for dy over dx. So now dy over dx is 3 by 2 t e raised to t cube minus t square plus 1, and to get the second derivative we'll differentiate both sides with respect to x. So d by dx of dy over dx, and we have here 3 by 2 and d by dx of t times e raised to t cube minus t square plus 1, right? And here we can see that we have the product of two functions. So now this is d2y over dx2, and here we have 3 by 2. Now see here we have the function of t. that is t e raised to t cube minus t square plus 1. And here we have to differentiate this function of t with respect to x. So what we will do, will here make use of the chain rule. So first we'll differentiate this function with respect to t. So here I will write d by dt of t e raised to t cube minus t square plus 1. And then we differentiate dt, that is t, with respect to x, right? So here what we have done here, to get the second derivative, we have 3 by 2 d by dx of the product of these two functions. Now here we have x. So what we will do, we'll differentiate this function of t with respect to t, and then by chain rule we have dt over dx, right? And from this expression, dx over dt is equal to 2t times e raised to t square minus 1. Dx, that is dt over dx, is equal to 1 over 2t e raised to t square minus 1, right? So here we'll substitute 1 over 2t times e raised to t square minus 1. So now we have 3 by 2. Here we'll use the product rule, that is d by dt of uv. If u and v are functions of t, then we have u, then we have dv over dt, and then we have v and du over dt, right? So we can take the first function u as t and v as the second function, right? So we have t, then the derivative of uh, e raised to t cube minus t square plus 1, and then we have e raised to t cube minus t square plus 1, and the derivative of t with respect to t, and then dt over dx is 1 over 2t, and here we have e raised to t square minus 1. So now d2y over dx2 is equal to 3 by 2, and then we have t. The derivative of e raised to t cube minus t square plus 1 with respect to t cube minus t square plus 1 as the exponential function itself. So we have e raised to t cube minus t square plus 1, and then by chain rule the derivative of t cube minus t square plus 1 is 3t square minus 2t. And then we have here e raised to t cube minus t square plus 1 times the derivative of t with respect to t is 1, and here we have 1 over 2t and e raised to t square minus 1. So now we have to simply reduce this expression into a simple form. So we have 3 by 2. We can take this factor common. So we have e raised to t cube minus t square plus 1, and in the brackets we have t times 3t square minus 2t plus 1, and here we have 1 over 2t e raised to t square minus 1. So now this is 2 times 2 is 4, so we have 3 over 4, and then here we have this factor t, and then we can take this e raised to t square minus 1 to the numerator. So we have e raised to t cube minus t square plus 1 minus t square and plus 1, right? So taking e raised to t square minus 1 to the numerator, and here we have 3t cube minus 2t square plus 1, right? Okay, so now we have 3 over 4t, and e raised to, here we can see that we have e raised to t cube minus t square is minus 2t square, and 1 plus 1 is 2, right? And in the brackets we have 3t cube minus 2t square plus 1. So the required expression for the second derivative of y with respect to x is given by this expression.